This Coast and Climate Hurricane Week special is sponsored by Eva Lagarde Center for Coastal and Environmental Studies.
Hi everyone, meteorologist Steve Caparotta here. It is Hurricane Week on Coast and Climate. We're going to have new guests joining me each and every day this week as we move into the first part of the hurricane season and help get you ready. And really excited to have my guest today, Dr. Phil Klotzbach. Let me tell you a little bit about Dr. Klotzbach. He's a research scientist at Colorado State University. Got his bachelor's in geography from Bridgewater State. Went on to get his master's and PhDs there at Colorado State. Worked under Dr. Bill Gray. We'll talk about that. Dr. Bill Gray, a legendary tropical weather scientist. And Dr. Gray really kind of initiated this whole idea of seasonal hurricane forecasts. But Dr. Klotzbach kind of worked with him for a number of years and took over as the lead author. It was even hard for me to believe this when I saw it, 2006. That's been that long. He's been the lead author on it. And he's had a lot of good peer-reviewed work also published. So with that, let me bring in Dr. Phil Klotzbach. Phil, thank you for joining me today. Really appreciate you being here.
Yeah, thanks so much for having me, Steve. Hope you're doing well.
I am doing well. So before we get into kind of the serious stuff, when I have guests on, I like to, because we get a lot of younger people and kids watching, I'd like to hear a little bit about your story. Tell me about when you first got interested in weather, when you first got into maybe hurricanes, and kind of how you ended up where you are now.
Yeah, I mean, I've always been kind of obsessed with the weather since I was a little kid. I can't remember when I wasn't interested in the weather. And so when I was 5 years old, Hurricane Gloria, so I grew up in Massachusetts, and Hurricane Gloria made landfall in Connecticut, but it brought some pretty significant winds up into southern New England. And then really, I think what kind of clinched the hurricane focus for me was a Hurricane Bob in 1991, which is not quite a direct hit, but even closer, and caused a decent bit of wind and storm damage, or wind and rain damage where I was growing up. So I've always been really interested in the weather. As you mentioned, I went to Bridgewater State College. I got my undergraduate degree in geography, and I was actually taking a climate class at Bridgewater State College. And I wanted to do something with hurricanes, and the professor who's teaching the class said, hey, there's this guy at Colorado State University who forecasts hurricanes on a seasonal time scale. And I said, that's crazy. There's no way you can do that. And then so I started actually reading, basically some of his papers. And then I was like, wow, he actually does know what the heck he's doing. And then so I finished my degree at Bridgewater State, took a year off, and mapped public transit bus routes. And then went and applied to graduate school. And Dr. Gray actually called me on the phone, and he was like one of my idols effectively at that point, and said, hey, we'd love to have you come out to CSU. And I went out to CSU, studied with him and worked with him closely for over 15 years. And I'm still at CSU. I've been at CSU for, I guess, pushing 22 years now.
So going from mapping public transit routes for buses to now renowned hurricane forecaster, what a career path. So I think people always find this a little bit interesting to hear. They're always a little bit, some people are confused by the idea that these seasonal hurricane forecasts are originating from somebody at Colorado State. Can you talk a little bit about the legacy of the late Dr. Bill Gray and how this all initiated and how it continues to go on today?
Yeah, and so, it was interesting. So the gentleman who actually started the department out at Colorado State, his name was Herbert Reel. And Herbert Reel was a really big-time tropical meteorologist in the 1950s. And so CSU wanted to start an atmospheric science department. And so they contacted him. And Herbert was actually at the University of Chicago at the time, which is still really nowhere near where hurricanes are. And so he started the department, and Dr. Gray was actually finishing off his PhD at the time. And so soon after he finished his PhD, Herbert Reel contacted him and asked him to come out and join the department as well. So it always has kind of had a hurricane focus. There's a whole lot of other research that's done in our department besides hurricanes, but it's always had somewhat of a hurricane focus. And so Dr. Gray, when people used to ask him, why seasonal forecasts coming from Colorado, he would say it's because the storm surge can't get you at 5,000 feet.
I like that answer. So with that, that's a good segue to the seasonal forecast leading into this season. Now you'll have an updated outlook coming out in just a couple of days. I'm going to pull up what you released back on April 7th. So your forecast was 19 named storms, 9 hurricanes, 4 major hurricanes. And on the graphic I have up right now, we compare it to the long-term average over the last 30 years or so, and then just showing the hyperactive seasons of 2021 and 2020 as well. So explain for people how you come up with those numbers.
Yeah, and so this kind of goes back to you mentioned Dr. Gray did a tremendous amount with tropical meteorology, but one of the contributions that he's best known for is these seasonal forecasts. And so the way these seasonal forecasts come about is hurricane seasons are not random. There are basically precursor signals. So there's signals in the atmosphere and ocean that can tell you whether you're expecting above or below average hurricane activity. These certainly don't work out perfectly, but in general, you have one set of climate conditions prior to active seasons and a different set prior to inactive seasons. So one of the big factors that we look at every year, and one of the big things that Dr. Gray noted when he started these seasonal forecasts, is that when you have El Nino conditions, which is warmer than normal water in the eastern and central tropical Pacific Ocean, when you have El Nino conditions, what that tends to do is increase the winds high up in the atmosphere in the Atlantic at say 20 to 30,000 feet. And those stronger winds blowing out of the west tend to tear apart hurricanes as they're trying to develop and to intensify. So in the case of the 2022 Atlantic hurricane season, which is fast approaching, we are not anticipating El Nino conditions. We actually have right now the opposite of El Nino, which is known as La Nina. That's colder water in the eastern and central tropical Pacific Ocean. And what that tends to do is generate winds that are more conducive for hurricane formation and intensification.
And we're not only not in El Nino, this, as you mentioned, this La Nina, the potential that maybe La Nina lingers through part of the season. Pretty unique in that this would be the 3rd straight year potentially with La Nina conditions around, right?
Yeah, that's correct. We have had a pretty long-lived, so it's kind of been waffling between La Nina conditions and what's basically known as neutral conditions, which is neither El Nino nor La Nina, but we've generally been in a more La Nina-like environment these past few years. And honestly, even if you look at, say, the last 20 years, we've generally had more La Ninas, fewer El Ninos than we say did in the 80s and 90s. And even looking back at some historical data, this is probably the most kind of La Nina-like 20-year period that we've had, going back even to the late 19th century, which is one of the reasons why the Atlantic has been very, very busy. La Nina favors Atlantic hurricane activity, but at the same time, it actually disfavors storm activity in the Pacific Ocean, where you get hurricanes and also typhoons, which is what we call hurricanes in the western North Pacific. So if we look globally at storm activity, while the Atlantic's been up the last 20 to 30 years, the Pacific Ocean's actually gone down. And since the Pacific Ocean is a much larger ocean, a larger area of warm ocean water there, when you actually decrease storm activity in the Pacific Ocean, overall globally you get a decrease in storms. And that's something we found in a paper that we just published a few weeks ago.
I think that's a great point because, a lot of people jump to the conclusion when you see all these storms in the Atlantic, say, boy, this must be the result of climate change, right? That's one of the things people immediately leap to. But usually in the tropics, as one basin is up, another is down. There's almost a seesaw type effect. So numbers have been down in parts of the Pacific, as you say, and that climate change connection, that is one of the points that's still kind of debated in the science community on how this works with tropical cyclones and what that connection might be. Still trying to figure that one out, I think, is a fair way of putting it. So let me ask you this. So most people say, okay, so we've got these numbers now, 19 named storms, 9 hurricanes. That was your April outlook for the upcoming season. But people say, okay, is one going to hit me? What can you tell people when it comes to maybe at least regional level outlooks?
Yeah, so we do probabilities of landfall. So we can't say months in advance when or where storms are going to strike. But in general, more active seasons do have more landfalling hurricanes. Now, there's certainly examples of fairly quiet seasons or very quiet seasons that have one or more significant hurricanes. For Louisiana, 1965, in general, was a pretty quiet hurricane season, but a very, very significant hurricane in South Louisiana with Hurricane Betsy. Another great example is 1992. Dr. Gray wasn't doing seasonal forecasts in 65, but he was in 92 and had a great forecast that year of only one major hurricane. And that one major hurricane was the A storm, Andrew, and it didn't form till late August. So an extremely quiet season, but that one major hurricane, obviously being Andrew, a Category 5 hurricane, slammed into South Florida. But in general, more active seasons do have more landfalling hurricanes. Recent example of that being, say, for example, the 2020 Atlantic hurricane season, which certainly, obviously, don't need to tell people in Louisiana, was extremely busy in Louisiana. So in general, more active seasons do have more landfall. So we do provide probabilities of landfall, but we do emphasize that, regardless of seasonal outlooks, these outlooks certainly aren't perfect. And even if they are perfect, we can't tell you where the storms are going to go. So people living along the coast need to prepare the same for every hurricane season, regardless of our seasonal forecast issued by one of the dozens of other groups that does them, such as NOAA and a bunch of other universities and private sector weather companies as well.
You kind of led me right into my next question. So how well do your forecasts verify? And people can actually look that up on your website, correct?
That's correct, yeah. So we've been doing this since 1984. I was not involved in the first seasonal forecast in 1984. I was starting nursery school that year, but the seasonal forecast, we do have every single forecast scanned in as a PDF, and we actually have charts and tables kind of showing how well these forecasts verify. So, the scale of these forecasts does improve as we get closer to this hurricane season, which makes sense. Since we're closer to the events we're trying to predict, similar to the way that your forecast for tomorrow is in general going to show more skill than your forecast for the weather, say, 3 to 5 days from now. So we issue our first forecast in April. We update it around the 1st of June. Then we'll update it again in early July and a final update in early August. And even though early August, you're already 2 months into the hurricane season via the calendar year, so 2 of the 6 months, so you're a third of the way through the season, over 95% of all your major hurricane activity, your Category 3, 4, 5 hurricanes, occurs after that point. But in answer to your question, on average, our forecasts, I would say, if say the forecast is for 8 hurricanes, typically the error bar is plus or minus 2. So if we're say forecasting, in this case, 9 hurricanes with our April outlook, the margin of error is between 7 and 11. On average, you would expect the forecast to fall somewhere between 7 and 11 hurricanes.
So the next question that naturally comes up, and I know it's one you get all the time, but some people say, okay, what's the value in these forecasts? How are they useful? What's the utility? So what would you say to that?
Yeah, I mean, these forecasts are more of an informational tool because, we do have skill at being able to predict how busy the hurricane season is going to be. And there's a lot of curiosity amongst the general public in the private sector as well as in the public sector in terms of, how good or basically how busy do you think the season's going to be. So from an informational tool, it's useful. But again, we do stress it's not a preparedness tool. We want everyone to prepare the same for every hurricane season. And as you've, as this week is highlighting, now is really the time to be prepared because, you don't want to be doing these things at the last minute. It's best to have everything ready to go. And then, if these storms do threaten, to follow the advice of your local emergency management.
So we'll be looking out for your next seasonal forecast coming out later this week. But I did want to talk to you about one other thing today. You have one paper has been published. I think the other's in review right now. But you've written on this idea that maybe the maximum winds in a hurricane and the Saffir-Simpson scale might not be the best measure of damage potential that comes along with a storm or a hurricane. So explain that and what you think is the best measure of that damage potential.
Yeah, so the Saffir-Simpson hurricane wind scale has been used to categorize hurricanes for about 50 years. And so basically that is the stronger the winds that they measure in a hurricane, the higher the category of the hurricane. So you probably have heard, a Category 3 plus hurricane is a major hurricane on the Saffir-Simpson scale. That's winds of 111 miles per hour or greater. And while that scale works reasonably well with, some hurricanes, it doesn't work well with other hurricanes, especially hurricanes that are extraordinarily small or large. And for a good example of a large hurricane, it's obviously still well remembered by people in Louisiana, would be Hurricane Katrina. Katrina was listed as a Category 3 hurricane on the Saffir-Simpson wind scale when it made landfall. However, Katrina, as you probably know, was a very, very large hurricane. And so one of the things that we advise people to be looking at when it comes to hurricanes is look at the pressure that the hurricane has, because hurricanes' winds are dictated by the difference in pressure. So the gradient in pressure between kind of the environment. So if you look at this figure here, you can see, kind of the clear area outside of the hurricane and the pressure in the center of the hurricane in the hurricane eye. And so if you have a storm like Katrina where the winds are high, but not that high, given the pressure, what that means is you have a very, very large storm. And that means that gradient or the difference in pressure is spread out over a large area. And larger storms tend to have a larger area of wind, a larger area of rain, but also tend to have more storm surge. And in the case of Katrina, we saw, over 25 feet of storm surge with that storm. And so what I was comparing that storm to was actually Hurricane Charlie in 2004, which was a nasty hurricane that went into southwest Florida. And Charlie obviously was a very damaging hurricane, had a lot of strong winds associated with it, but Charlie was a much smaller storm in size. And so the area that it hit extremely hard. But even though it went into southwest Florida, which is extremely storm surge prone, the surge from Charlie was much smaller because it was a much smaller storm in size. So we are advocating that we should be using pressure to categorize hurricanes as opposed to wind. One of the reasons being that it is just much, much easier to measure the pressure in a hurricane, both if you're flying an aircraft in a hurricane. So when hurricanes are approaching the coast, what we do is the Hurricane Center will fly airplanes into those storms. So there's NOAA airplanes as well as Air Force airplanes. And what they'll do is they'll measure the environment around the hurricane, and then they'll fly through the hurricane, trying to estimate its intensity, both from wind and from pressure. And so if you're trying to measure the winds in the hurricane, that's extremely challenging. We generally know kind of the broad area where those strongest winds are likely to be. But a hurricane is a big swath of wind, and so trying to figure out exactly where those strongest winds is extremely challenging. Whereas measuring the pressure in a hurricane is pretty straightforward. Basically, we can fly the hurricane or fly the airplane into the hurricane, get into the center of the hurricane in the eye, and drop us on, and you can measure the pressure quite accurately. Also on land, once the hurricane has made landfall, anemometers, which are devices that measure wind, chronically fail. Once the storm makes landfall, the anemometers chronically fail, whereas a barometer doesn't even need to be outside to accurately measure the pressure in a hurricane. And so historically, we've actually shown that if you look at the damage from hurricanes, that the damage actually correlates stronger with the pressure than it does with the wind.
Since you brought that up, let me bring up a couple of graphics that you shared. So for some people, I know it's going to be a little tricky to read, but we do have some science nerds that watch this. So explain what we're looking at here right now when we look at this graphic that's kind of showing damage versus maximum winds.
Yeah, so each of these plots, or each of these dots is a hurricane that has made landfall since 2007 in the continental U.S. And so here we're looking at ranks. So basically higher storm ranks indicate stronger damage and stronger winds. And so in this case, Vmax is representative of the strongest winds in the hurricane. And so you can see on the left-hand side, you see storms like Arthur and Barry, fairly weak hurricanes, not a ton of damage. And then if we move up towards the right-hand side, you can see storms that people are likely quite familiar with, like Ida and Harvey and Irma. And so the reason that we use ranks instead of overall damage is because you get a couple of these storms just caused an overwhelming amount of the damage. And so that would really kind of skew your statistics. But you do also see Hurricane Sandy. While Sandy was officially post-tropical, we do include it in this analysis because Sandy was an extremely large storm and was classified as a hurricane until just a couple of hours before it made landfall. But you can see, for example, on this chart, there's a lot of spread. Some of the storms fit close to the line, but there's a lot that don't. And so they're saying that there's just a lot of variability in the damage that we can't really explain with wind. But if we go to the next slide and look at what we see when we have pressure, thanks, Steve, you can see that the slope of the line is a lot steeper and that the storms generally fit much closer on the line, indicating that you get a much better fit. Not perfect. We have a storm, for example, like Isaias, which was a very damaging storm, but not particularly strong when it made landfall, but it went up the East Coast, impacted a lot of major metropolitan areas, and also was fairly close to the coast, so it really did lose steam very quickly in terms of the weakening of its winds. But just simply by knowing the pressure, we get much better correlations with the damage that these hurricanes cause. And this says nothing about either the rainfall that the storm generates, and also says nothing about the population that is impacted, because obviously if you have a very strong hurricane, but it makes landfall in an area with very few people, it's going to cause a lot less damage. But overall, we're saying here you can see a lot better correlation with the damage using pressure versus wind. And we actually took this study back to 1900 and looked at damage versus wind and pressure back over 120 years. And you still see pressure working better than wind. And it's really important, especially for storms, making landfall kind of in the neck of the woods where I grew up. Storms from Georgia to Maine, you get a much better correlation with pressure than you do with wind for those storms. And I think it's because storms making landfall along the East Coast tend to be larger. Older storms in general tend to be larger in size. So these storms tend to be large, maybe a bit sprawly. So they may not have, super strong winds, but they're large storms and tend to have more storm surge associated with them.
I think it's a great explanation of that, and sort of the complexities that go into this, although the beauty, I think, of what you're proposing, as you say, is that minimum central pressure is something we have a good handle on and that we measure easily and readily and do really well with getting in our storms. So we'll see how that plays out with time. Before I let you go today, in addition to being a seasonal hurricane forecaster and a researcher, I think you're a great hurricane historian. So I just wanted to get your perspective on what Louisiana has seen these last couple of hurricane seasons when you consider all the hits. You had 3 major hurricanes make landfall in the state in the course of a year and 2 days. And I forget how many cones we were in 2020, excuse me. But it's just been remarkable. Give us some perspective on that from, excuse me, somebody like you that's been at this for a long time and really understands hurricane history.
Yeah, I mean, the last couple of years, for Louisiana has been just an extremely, obviously, busy time. I don't need to tell people living there of that. But yeah, the sheer number of, obviously significant hurricane impacts, and as you mentioned, just how many times various parts of the state have been in the cones of uncertainty, and especially with like storm surge watches and warnings. It's been an extremely busy time for the state of Louisiana. Obviously, the Gulf of Mexico in general has been very, very busy the past couple of years. Unfortunately, there's not a lot that we can say, for the 2022 season, will the Gulf of Mexico be busy again this year? In general, the Gulf of Mexico, unfortunately, tends to be an area with lower overall predictability on a seasonal timescale, not an individual storm timescale, but on a seasonal timescale. So it's a bit hard to be able to address, exactly if we're going to see another really busy year for Louisiana in 2022. But certainly I wouldn't say, just because the last 2 years have been extremely busy, that we expect this to be the quote unquote new normal. We heard a lot of that after 2004 and 2005, which were 2 extremely busy seasons. A lot of people are saying, no, this is the new normal. Every year is going to be like this. And then the U.S. actually went 11 years without one major hurricane making landfall. And obviously, it seems like a long time ago now, but in years like 2016 and even into 2017, we were talking about hurricane amnesia and people kind of forgetting about hurricanes and that they're not a problem anymore. But certainly after the last 5 seasons, especially 2017 through 2021, those 5 seasons, people are certainly no strangers to hurricanes anymore.
You took the words out of my mouth. That major hurricane drought feels like eons ago after just the last 2 seasons, everything we've been through. All right, so later this week, you'll have your updated seasonal outlook. People like myself, the media, we share the numbers, but tell everybody where they can find it. Maybe if they want to read the whole report, the past outlooks, and see the verification numbers, how do they find all that?
Yeah, so we have a website, tropical.colostate, so colostate.edu. And on that website, we have all of the forecasts going back all the way to 1984. So Steve mentioned, the forecasts do come out with numbers, but there's a lot that goes into those predictions. We use a lot of different techniques to come up with those numbers. We discuss kind of the errors and uncertainties associated with those forecasts. And then we go through a lot of detail describing kind of the large scale environment. So what's going on in the atmosphere and ocean to make us either, lower our numbers, keep our numbers the same, or even increase our numbers. So, that's really where I would suggest you go if you really want to see the nuts and bolts of the forecast. Because again, while the forecast numbers are out there, we do actually put out a 30 to 40 page document with each of these forecasts kind of going into a lot of detail, discussing really, what we see. And then at the end of each year, we also do an extensive verification of the predictions, say what went well, what went poorly, and then kind of try to give some physical insights as to what kind of drove whatever we observed in that particular season.
Okay, so be sure to check that out. Dr. Phil Klotzbach from Colorado State, thank you so much for your time and join us here on Coast and Climate Hurricane Week today. And hey, let's all hope for a quieter hurricane season this year, right?
Sounds good. Thank you, Steve.
All right, Dr. Phil Klotzbach, thank you once again. We're going to pick up Coast and Climate Hurricane Week at the same time tomorrow, 3:15 on Wednesday. And tomorrow I'll be joined by Dr. Jack Bevan. He's a senior hurricane specialist with the National Hurricane Center. And notably, he was the lead author on the Hurricane Ida report. He also happens to be a Baton Rouge native, graduated from Catholic High. So looking forward to his perspective on why Ida did not get the upgrade to Category 5 and maybe a little bit about what he does at the National Hurricane Center. So again, join us right here, same place, WAP Plus or the Hurricane Center on WAP.com for a new episode of Coast and Climate Wednesday at 3:15.
This Coast and Climate Hurricane Week special is sponsored by Eva Lagarde Center for Coastal and Environmental Studies.